Topic: Electrochemical reactions. Aims of lessons: electrolytic cells and galvanic/voltaic cells. Define the galvanic cell as a cell in which chemical energy is converted into electrical energy. A galvanic, voltaic, cell has self-sustaining electrode reactions. Define the electrolytic cell as a cell in which electrical energy is converted into chemical energy. Define oxidation and reduction in terms of electron, transfer. Oxidation is a loss of electrons. Reduction is a gain of electrons. Define oxidation and reduction in terms of oxidation numbers. Oxidation, an increase in oxidation number. Reduction, a decrease in oxidation number. Define an oxidizing agent and a reducing agent in terms of oxidation and reduction. Oxidizing agent, a substance that is reduced/gains electrons. Reducing agent, a substance that is oxidized/loses electrons. Define an anode and a cathode in terms of oxidation and reduction. Anode, the electrode where oxidation takes place. Cathode, the electrode where reduction takes place. Define an electrolyte as a solution/liquid/dissolved substance that conducts electricity through the movement of ions. Electrolysis, the chemical process in which electrical energy is converted to chemical energy or the use of electrical energy to produce a chemical change. Relation of current and potential difference to rate and equilibrium. Give and explain the relationship between current in an electrolytic cell and the rate of the reaction. State that the potential difference of a galvanic cell is related to the extent to which the spontaneous cell reaction has reached equilibrium. State and use the qualitative relationship between cell and the concentration of product ions and reactant ions for the spontaneous reaction, namely cell decreases as the concentration of product ions increases and the concentration of reactant ions decrease until equilibrium is reached, at which the cell equals zero, the cell is a flat. Qualitative treatment only. Nernst equation is not required. Understanding of the processes and redox reactions taking place in galvanic cells. Describe the movement of ions in the solutions. State the direction of electron flow in the external circuit. Write down the half reactions that occur at the electrodes. State the function of the salt bridge. Use cell notation or diagrams to represent a galvanic cell. When writing cell notation, the following convention should be used. The H2H plus half cell is treated just like any other half cell. Cell terminals, electrodes, are written on the outside of the cell notation. Active electrodes, reducing agent oxidize species, oxidizing agent reduce species. Inert electrodes, usually point or C point, reducing agent oxidize species, oxidizing agent reduced species point. Example, PTS-C-AQ, C2G, F2G, F-AQ, point S. Predict the half cell in which oxidation will take place when two half cells are connected. Predict the half cell in which reduction will take place when connected to another half cell. Write down the overall cell reaction by combining two half reactions. Use the table of standard reduction potentials to calculate the EMF of a standard galvanic cell. Use a positive value of the standard EMF as an indication that the reaction is spontaneous under standard conditions. Standard electrode potentials. Write down the standard conditions under which standard electrode potentials are determined. Describe the standard hydrogen electrode and explain its role as the reference electrode. Explain how standard electrode potentials can be determined using the reference electrode and state the convention regarding positive and negative values. Resources: paper-based resources. Learners are referred to the electrochemical cells topic in the textbook or study guides that learners will have on hand. Examination Guideline, page 22 to 23. Mind the Gap books, pages 155 to 192. Past NSC examination papers, refer to Paper 2. Digital resources. Refer to the relevant digital resources. www.wseedportal.co.za. Hey Science app for physical sciences. Past NSC examination question papers. YouTube videos. Introduction to galvanic cells. https://youtube.be/9blb-umtim. Electrochemistry practice problems and introduction. https://youtube.be/s9ifrctwdil0. Introduction Parts 1, 2 and 3. 1. You should be able to explain what a voltaic cell is. Use the CU/ZN voltaic cell. Read through Mind the Gap pages 169 to 173. 2. You should be able to explain how a voltaic cell operates, the electrode at which oxidation occurs and the electrode at which reduction occurs. 3. You should be able to explain the movement of electrons from anode electrode to cathode electrode in external circuit and movement of ions through the salt bridge in the internal circuit. 4. Observe the following YouTube videos. Introduction to galvanic cells. https://youtube.be/9blb-umtim. Electrochemistry practice problems and introduction. https://youtube.be/s9ifrctwdil0. 5. Now attempt the following activities from Mind the Gap. Page 172, Activity 7. Page 175, Activity 8 and 9. Page 176, Activity 10. Concepts and Skills Part 4. You should be able to explain how a standard hydrogen electrode works. Read through Mind the Gap pages 178. You should be able to calculate the EMF of an electrochemical cell. Now go through the worked examples on page 181 to 184. Can you explain what a voltaic cell is? Explain oxidation and reduction (ETO). Electron transfer. Define what an oxidizing agent and reducing agent is. Identify the electrode where oxidation and reduction occur in a voltaic cell. Identify the anode and cathode in a voltaic cell. Identify the direction of movement of electrons in the external circuit and the movement of ions in the internal circuit. Calculate the EMF of a voltaic cell. Write down the cell notation. Activities/assessment Part 5. Now practice the activities 10 to 17. Consolidation. Work through practice questions on pages 4, 5, 7, 13 and 14. Link, https://drive.google.com/files/d/140/mdacpyexqyme-rsp/view?usp Values, observation, identify, analyzation, making conclusions. Thanks for watching. Please do not forget to like, share and most important subscribe to the channel.